everyone, it's Mrs. Martello. We're going to look at section 3.1 and we're going to start talking about functions. So first in this paragraph here, we're introduced to the word relation. A relation just pairs inputs with outputs. If you think about like a machine or like a conveyor belt, whatever you put in is going to be a certain value, and then something happens to that value and it comes out, there's an output. So if you think about it in terms of like an equation, usually x is the input and y is the output, usually, but not all the time. So when a relation is given as an ordered pair, the x coordinates are the inputs and the y coordinates are the outputs. And a relation that pairs inputs with exactly one output is a function. Now this is a really important definition, so I actually wrote it down on my piece of paper. If you want to pause the video and copy this down as well, this is really important for you to know that in order for a relation to be a function, each input can only be paired with one output. So that means that anytime you are given an x value, it can only be paired with one y value. It can't have different y values. So let's look at some examples so that we can see what we're talking about here. Let's look at example 1. We want to determine whether the relation is a function and explain. We're just going to look at 1a. So we have a set of ordered pairs here, and we want to focus on the x's and what the x's are paired with. So in this first point, this ordered pair, -2 is paired with 2. So what I want to do is I want to look to see if there are any other x's that are -2 that are paired with a different y. So look at this x, no, 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 no. Okay, there are no other -2 x's that are paired with any other y, so we're good so far. Let's check the second point. -1 is paired with 2. Let's look to see if there are any other -1s as x's that are paired with different y's. So this is not -1, no, no, so we're still good. Check out this x, 0 is paired with 2. There are no other zeros for x's paired with different y's, so it's still okay. This x is 1, it's paired with 0. There's no other 1 that's paired with a different y, so we're okay. And then this x is 2, and it's paired with 0. There's no other 2 as an x that's paired with a different y, so this one is okay. So for 1a, each input has exactly one output, therefore the relation is a function. Okay, be careful with this. What I want you to notice is look at how the y's are allowed to be the same number. How this y is 2, and this y is 2, this y is 2, this y is 0, this y is 0. That's totally fine. It doesn't matter about the y's. It matters that each x is only paired with one y. Let's look at example B. So in this example, I have 4 as my x. It's paired with 0. Let's look to see if there's another 4 that's paired with a different number. So here, look at this point. 4 is now paired with 3. But up here it said 4 was paired with 0. That is against the rules. We can't have that. 4 can only be paired with one y. So because of this, right away, my answer is no, this is not a function, because the input 4 is paired with 2 different outputs. It's paired with 0, then it's paired with 3. That's not allowed. It can only be paired with one output. So the input 4 has 2 outputs, 0 and 3, therefore the relation is not a function. Okay, let's take a look at letter C. So this time our inputs and outputs are given to us as a table, and these are just ordered pairs. So this would be the ordered pair -2, 3. This would be the ordered pair -1, 4. It's just given to us in a table. So now look at the inputs. Are there any other -2s? No. Any other -1s? No. Okay, this 0 is paired with 5, but then this 0 is paired with 6. That is not allowed. I cannot have 0 paired with 2 different outputs. So again, this is against the rules. This would not be a function. So the input 0 has 2 outputs, 5 and 6. Therefore, the relation is not a function. Let's look at letter D. So this is called a mapping. So the inputs are put in this oval over here, and the outputs are put in this oval over here. And it's a mapping to show that -1 is paired with 4, 3 is paired with 15, and 11 is paired with 15. So this is called a mapping. Let's see, is this a function? So -1 is paired with 4. Is -1 paired with any other number? Nope, it's only paired with 4. 3 is paired with 15. Is 3 paired with any other number? Nope, it's only paired with 15. And then 11 is paired with 15. Is 11 paired with any other number? Nope, so this one is okay. This is a function because each input only points to one output. So this is a function. Okay, so notice how this is pointing both at the 15. That's okay. The y's are allowed to be the same. It just matters that the x's can't go to different y's. All right, let's take a look at 2 more examples. Let's see if we can do these here. We're gonna look at monitoring progress number 2. So in monitoring progress number 2, let's take a look at this set of ordered pairs. So I see -4 is paired with 8. Is there any other -4 as an x that's paired with a different y? No, we're okay. -1 is paired with 2. Is there any other -1 paired with a different y? Nope, we're okay. 2 is paired with -4. Is there another 2 as an x paired with a different y? Nope, we're still okay. And then 5 is paired with -10. There's no other 5 as an input that's paired with a different output. So this is a function. So we're going to explain. Number 2 is yes, this is a function. It is a function because each input is paired with exactly one output. Okay, so that is a function. Let's take a look at monitoring progress number 4. So this is a mapping again. We have our input. There's only one input of 1/2. 1/2 is paired with -2. Then it's paired with 0. Then it's also paired with 4. That is definitely against the rules. This input can only be paired with one output, but this input is paired with 3 different outputs. This is not a function. So not a function because the input 1/2 is paired with more than one output. It's paired with 3 different outputs. Okay, so that's determining if a relation is a function, and that is an important idea to know if it's a function or not. And this is based on looking at ordered pairs. So now what we're going to do is looking at a graph, we're going to decide if it's a function. And actually it's a lot easier when you think about it as a graph. And there's a little trick, it's called the vertical line test. So a graph represents a function when no vertical line passes through more than one point on the graph. So if I look at this example here, if I draw a vertical line anywhere on this graph here, any vertical line that I would draw, it would only pass through one point. This would be a function because it passes the vertical line test. Each vertical line only passes through one point, which is what I want. And think about how this relates to the definition of what a function is. Each x is paired with one y. So whatever this x is, there's only one y. There's no other point along this vertical line. It doesn't have a different y. Whatever this x is, it only has this y. There's no other y along this x coordinate that it would be. So this is according to the definition, but the vertical line test is a nice visual way to look and see if it's a function or not. Let's look at this example. If I pick any point over here to the left side, it passes through 2 times, passes through up here and down here. That is not allowed. This has 2 different outputs and it does not pass the vertical line test. It should only pass through 1 time, so this is not a function. Let's take a look at example 2. We're going to use the vertical line test to determine if the graph represents a function. So in 2a, think about the vertical lines you would draw. This vertical line only passes through 1, but then look at this vertical line. It would pass through 2 points. That breaks the rules. The vertical line test only can pass through 1 point. And then over here it breaks the rule again. So you can even see here, it's definitely not a function because you can draw a vertical line through more than 1 point, so it does not pass the vertical line test. Let's look at B. So anywhere I draw a vertical line here, it's only passing through this line 1 time. So this is a function because it passes the vertical line test. Each vertical line only goes through 1 point. Okay, let's go on to the next idea here. The next idea we're going to talk about is domain and range. So the domain, I'm going to write this down because this is important vocabulary. The domain is the set of all inputs. Remember that the inputs are the x's. So when you list out all the x's, that's called the domain, or what the x's can be. Then the range is the set of all outputs. Remember, our outputs are the y. So you're just saying what all the y coordinates are or what they can be. Okay, so that's domain and range. Let's take a look here. In example 3, we want to find the domain and range of the function represented by the graph. So we're going to look at letter A. Letter A has all of these separate points. I basically just want to say what are the x coordinates of the points and what are the y coordinates of the points. Since they're all separate points, they're all individual points, I'm going to list them out as just each individual number. So this point, the x is -3. That's the first number in our domain. For this point, the x is -1. That's the second number in our domain. For this point, the x is +1. That's the third number in our domain. And this x is 3. That's the fourth number in our domain. So our domain would be -3, -1, 1, and 3. And those are just the x coordinates of these points. Now let's talk about the range. The range would be the y coordinates of these points. So this point's y is -2. That's the first number in the range here. This point's y is 0. That's the second number in the range. This point's y is 2. There's the third number in our range. And this point's y is 4. And that's the fourth number in our range. So our range is -2, 0, 2, and 4. So when it's individual points like this, you're just listing out the numbers for each x and y coordinate. For letter B, it's a little different when the graph is connected like this. When it's connected, remember that it's everything in between the points. It's not just this point and this point, it's every single number in between, integers and real numbers. So it could be decimals or fractions anywhere in between here. So our domain really goes from this number all the way to this number, and we're going to write it as a compound inequality with an and. Compound inequality, like how we learned last chapter. So our x's go in between these two numbers. Let's say the x coordinate of this point, it would be -2, and the x coordinate of this point would be +3. So our domain is everything from -2 to 3. So our domain is -2 is less than or equal to x, which is less than or equal to 3. Notice how it's less than or equal to because these are closed circles, so it can equal it. And notice how x is in the middle because we're talking about domain, which is all the x's. Let's do the range next. So for our range now, we want to think vertically. Remember, we want to go small to big, so we're going to go bottom to top. So the bottom, the lowest y this point is here is -1. And then up to the top of the graph, the highest y over here is 2. And all the y's are in between -1 and 2. So our range is -1 is less than or equal to y, which is less than or equal to 2. Okay, we're gonna do one of these together. I think that the connected graph is a little bit more tricky with this, so why don't we do monitoring progress number 10. All right, so here we're gonna look at number 10. In number 10, we're gonna look at the domain and the range. So for our domain, we're gonna look at the x's, and they go from this x all the way to this x, and it's everything in between. This x is 1, and this x is 5, and our x's are in between 1 and 5. The circles are closed, so I'm gonna say or equal to. So 1 is less than or equal to x, which is less than or equal to 5. Let's do the range. Our range are the y coordinates, and we're gonna go from the bottom to the top. So our lowest y down here would be 0, and our highest y up here would be 4. So we're gonna go between 0 and 4, and all the y's are in between. Again, they're closed circles, so we're gonna use less than or equal to. 0 is less than or equal to y, which is less than or equal to 4. Okay, we're gonna take a look at our next set of vocabulary terms, which is independent and dependent variables. The independent variable is a good vocabulary term that we should know, and I'm gonna write it down on my paper here. So the variable that represents the input values of a function is the independent variable, because it can be any value in the domain. It's independent of anything else that's happening. It's basically something that you can determine. You can decide what the independent variables are. So it's the input values of a function. And the key to this is that you can change these. You can determine or change these values. It's something that you can control. You have control over this. Those are the independent variables. The dependent variables, those are the output values of a function. And the dependent variables are literally depending on the independent variables. They literally depend on the independent values. So it means that the independent values determine what the dependent values are going to be. Let's look at some examples of this. So in example 4, it says the function y equals -3x plus 12 represents the amount y in fluid ounces of juice remaining in the bottle after you take x gulps. Identify the independent and dependent variables. So our independent variable is something that I can control. Our two variables here are y, which is the amount of juice left in the bottle, and x, the number of gulps. Well, I determine how many gulps I'm going to take. I can take 1 gulp, I can take 2 gulps, I can take 3 gulps. That means that the number of gulps is the independent variable. Whereas the y literally depends on the x. The amount of fluid left in the bottle depends on how many gulps you've taken. So the y is the dependent variable. So we're going to say here that the y is the dependent variable and the x is the independent variable. Okay, our next step for part B, it says the domain is 0, 1, 2, 3, 4. What is the range? So what they did is they made a nice table here as a visual representation. You basically just want to take each x and plug it into the equation and find out what y would equal. So if I plug in 0 into this equation, 0 times -3 plus 12 would be 12. Then I'm going to plug in 1 into our equation. -3 times 1 plus 12 would be 9. Plug in 2, plug in 3, plug in 4, and I would get 6 and 3 and 0. And then these values are all of our outputs, which would be our range. So our range would be 12, 9, 6, 3, and 0, just like that. Let's do another example like this. We're gonna look at monitoring progress number 12. So it says the function t equals 19m plus 65 represents the temperature in degrees Fahrenheit of an oven after preheating for m minutes. So think about what you have control over. You have control over the time. How much time are you gonna wait before you check the temperature? So the m minutes, that's the independent variable. Whereas the temperature literally depends on how many minutes have passed. So depending on how long it's been, the temperature is going to change. Therefore, the m minutes is our independent variable. That's something I have control over. I can wait a certain amount of minutes. But our T temperature, that's our dependent variable, because the temperature depends on how long the oven has been preheating. Okay, that's part A. Let's go on to part B. A recipe calls for an oven temperature of 350 degrees Fahrenheit. Describe the domain and range of the function. Okay, so this time they're giving me 350 as the temperature. So this 350 represents T. I'm gonna plug T in, our 350 in for T. So let's plug in 350 for T into this equation. We're gonna have 350 equals 19m plus 65, and then I can solve for m to see how long it's gonna take for our oven to get up to that temperature. So let's subtract 65 from both sides. Here I'm left with 19m equals, this would be 285. And then I'll divide both sides by 19. And I'm gonna use my calculator here just to make sure that I get this correct. So let's see, did I subtract correctly first? Minus 65, 285, yep, divided by 19, and I get 15. So 15 equals m. Now remember that our time is starting from 0. So it's starting from 0 and it's going up to 15 minutes. So describe the domain and the range of the function. We want to talk about preheating. How long does it take to preheat? And it's going to go all the way up to 15 minutes. So let's talk about our domain. Our domain is the amount of minutes. So we're going to go from 0 minutes to 15 minutes and all of the minutes in between. So it would be 0 is less than or equal to m, which is less than or equal to 15.